Hello, dear students. Today we are going to discuss Ohm's law. Ohm's law states that physical conditions like temperature, pressure remaining same, the electric current flowing through a conductor is directly proportional to the potential difference across the two ends of the conductor. That is, I is directly proportional to V, or we can say V is directly proportional to I. Changing the sign of proportionality into equality, we have to multiply it with some constant, which implies V is equivalent to I into R, where R is constant called resistance. The value of this constant depends on the nature, length, area of cross section, and temperature of the conductor. Also, V divided by I is equivalent to R. That means potential difference divided by current is equivalent to constant. The SI unit of resistance is volt per ampere. Volt is the SI unit of potential difference and ampere is the SI unit of current, which is called ohm and is represented by the Greek letter omega. The symbol of omega is this. 1 ohm is defined as the resistance of a conductor if a current of 1 ampere flows through it under a potential difference of 1 volt. If a graph is drawn between potential difference reading V and the corresponding current values reading I, the graph is found to be a straight line passing through the origin. A straight line graph can be obtained only if the two quantities are directly proportional to one another. We conclude that current is directly proportional to potential difference. It is clear from the graph OA that as the potential difference V increases, the current I also increases, but the ratio V divided by I remains constant. This constant is called resistance of the conductor. Factors affecting the resistance of the conductor. The electrical resistance of a conductor depends on the following factors. Number first, length of the conductor. It has been found by experiments that on increasing the length of a wire, its resistance increases, and on decreasing the length of a wire, its resistance decreases. Actually, the resistance is directly proportional to its length. That is, R is directly proportional to L. If the length is more, resistance is more. If the length is less, the resistance is less. Number second, effect of area of cross section of the conductor. It has been found that the resistance of a conductor is inversely proportional to its area of cross section. That is, R is inversely proportional to A, which means that a thick wire has less resistance and a thin wire has more resistance. Number third, effect of the nature of material of the conductor. The electrical resistance of a conductor depends on the nature of the material of which it is made. For example, if we take two similar wires having equal lengths and diameters of copper and nichrome alloy, the resistance of nichrome wire is about 60 times more than that of copper wire. Number 4. Effect of temperature. It has been found that the resistance of all pure metals like copper, silver, zinc, iron increases on raising the temperature and decreases on lowering the temperature. But the resistance of alloys like nichrome is almost unaffected by the temperature.